Good day, my name is Alex Matlase, and in this video we are going to do the grade 12 mathematics March paper that was written last year. This paper was written in Gauteng. So let's move through the paper. We have the instructions. Make sure that you familiarize yourself with the instructions before you start writing. Let's go straight to question 1. Question 1 is solve for x. So let's start with 1.1.1. So 1.1.1, it says x, open brackets, 2x minus 3, then this is equals to 0. Here the first thing to do is we have this x multiplied by this bracket. So what we must do here is we must apply the log that says a multiplied by b is equal to 0. This can be written as a is equal to 0 or b is equal to 0. So we can let our a to be this x, our b to be this 2x minus 3. So let's apply that rule here. Okay, let me use this. So the first thing to do is you're going to say x is equal to 0 or 2x minus 3 is equals to 0. Then we have the first solution. Then now we are looking for the second solution. What we are going to do is we are going to say 2x is equals to, then when you transpose the minus 3 to the other side, it gives you positive 3. Then you divide by 2, you divide by 2. Then x is equals to 3 all over 2. This is your final answer. And how do we then mark this? You get 1 there, you get 1. Then it's equals to 2 marks. Then let's look at the next question. 1.1.2. 1.1.2, it says 0 is equals to 3x squared minus 5x minus 11. So what are we going to do here? We are going to use the quadratic formula. So you can rewrite this. This is one and the same thing as 3x squared minus 5x minus 11 is equals to 0. Then we must know that this 3 here is our A, this minus 5 is our B, this minus 11 is our C. Then you use the quadratic formula. The quadratic formula says, since we're looking for x, so we're going to say x is equals to minus b plus minus the square root of b squared minus 4ac divided by 2a. Then we go to our A, B, and C. So what is B? B is equals to minus 5 plus minus the square root of, what is our B again? Our B, it's minus 5 squared minus 4 times, what is our A? Our A, it's 3. What is our C? It's minus 11. Then you do the division sign. So make sure, guys, when you put this in your calculator, you have one division line. You don't separate the minus 5 from the plus minus square root. Now, it must be one thing. So we're going to say divide by 2 times 3. Then our x values that we get, the first one should be minus 1,25, or x should be equals to 2,92. That is our next solution. Let me fix this one here so that I can see the marks. So how do we then mark this? We are going to mark the correct substitution and the two solutions. Then this is 3 marks. That's how we mark this one. Then let's move on to 1.1.3. 1.1.3, 3. The question says x, open bracket, 3x plus 4, then minus 2, 3x plus 4. Then this is less or equals to 0. What's the first thing to do here? We must distribute this x inside. So we are going to say x times 3x, which is 3x squared, plus x times 4, it's 4x, then minus 2 times, we distribute again, minus 2 times 3x and the plus 4 there. So minus 2 times 3x, it's minus 6x. Minus 2 times 4, that's minus 8. This is less or equals to 0. From here, we add the like terms. So we are going to say 3x squared, then 4x minus 6x. Put this in your calculator. Many people will write plus 2x, which is incorrect. Put this in your calculator and say 4 minus 6, it should give you minus 2x. Be careful of that. Many people are making that common mistake. From there, we are going to factorize this. So I advise people to use the quadratic formula when you are supposed to factorize, because it makes things easier. But if you can use the factors, it's also fine. But for this question, let's use the quadratic formula. So we are going to say what? We are going to say x is equals to minus b plus minus the square root of b squared minus 4ac divided by 2a. You must make sure that you label correctly. This is a, this is b, this is what? C. So we are going to say, what is b? B is minus 2, then plus minus the square root of, what is b again? Minus 2, open brackets, squared, minus 4 times, what is a? A is 3, c is minus 8. Then this is divided by 2 times. What is a? A is 3. From there now, your solutions, the first solution of x, you should get x is equal to 2, or x must be equals to negative 4 all over 3. These are your two solutions of x. But I forgot to look at something here. So we have an inequality sign. So when you have an inequality sign, let me correct this mistake, but I think it's still aligns with what you're doing. So let me bring down this thing. There's a small thing that I skipped. Okay, let me also bring that QF again to make things easier. So after the step here, let me wipe off that. After this step, you must say critical values. So here we are trying to find the critical values of this expression there. So to find the critical values, you will change this inequality to equals to. So now we must say 3x squared minus 2x minus 8, it's equals to 0. Then after, this is what we got as our critical values. These are your two critical values. When they say something is critical, it means that's important, or that's our reference. That's where we are let's say you're looking for directions. The first thing that you're gonna maybe reference to, you will say there's a hospital when you pass by the corner there. That's your reference. That's your important point. Same as this one here. X is equals to 2 and x is equals to minus 4 over 3. That's your reference. That's where we are referencing this function. So after that, writing this, you would have found your critical values. So let me correct this box here. So these are your critical values. After finding your critical values now, because of we are working with an inequality sign, there is an inequality sign. So since you are working with an inequality sign, you must write the number line. So we are going to write the straight line like that, then 2 arrows, then your critical values. The first value must be the smallest one, which is -4/3. The biggest one should be 2. So we are going to do 2 circles. From there, you decide, are the circles closed or open? The circle is closed because the inequality has a line below it. So it's closed. So we are going to shade the circle there. After, you must know that for a function, let's say, let me draw a parabola here. So here the points are less. So when you have, let's say, y, then x here. So y here is less. So it's negative here. But going this side, y is positive. Going this side, y is positive. So in between the 2 points, how is y? Y is negative. That's why we draw a negative line there. Then away from the 2 points, how is y? Y is positive. So that's why we put positive, positive. Then we go to our inequality side. We say, oh, the function is on the negative side. Let me wipe off this so that I get a straight line. So here we have our inequality side. This function is on the negative side. When I say 3 is less than 4, this 3 is less. I can represent that with a minus. This 4 is big, so I can represent with a plus. So this function here is minus. So in your number line, you are going to put it in between the 2 points. So that's how you are going to represent it on a number line. Then you must write the solution. The solution is x is between what? Is between -4/3 and 2. But they must be included. This is a mark. Or you can say, someone can say x as an element. Then square brackets, you say -4/3 is 2. That's also a mark. So talking about marks, let me also show you how are they gonna mark this. For you to use the quadratic, you get a mark, or someone might find factors. You get a mark for those factors that you got. Then for you to get these 2 critical values, let's say you found 2 and let's say you said x is equals to 2 or x is equals to 3, then it's highly incorrect. You don't get that mark. But here, the 2 points are correct. So we are going to get a mark. Then for you to write this solution, you're going to get another mark already. So this is 3 marks in total. Then let's move to the next question, which is 1.2. Move this a bit up. This is 1.2. 1.2 then says the roots of a quadratic equation in terms of p are given as follows. X is equals to 4 plus minus square root of 8 minus p cubed divided by p. Determine the values of p for the roots to be real. For roots to be real, there are 2 conditions. One, when you for roots to be real, the square root should be numbers that are positive, or numbers, or a number 0. Like when you put 0 here, the square root of 0 is 0. Or you can say the square root of 4, this is 2. But when you say the square root of minus 4, then now this is non-real. So now from these two, we can say that for a root to be real, it must be greater or equals to 0. So let's check our quadratic equation that we are given. We are given that x is equals to 4 plus minus the square root of 8 minus p cubed divided by p. So let's take a look inside there. That expression is inside the square root. For it to make this solution to be real, we have to make sure that 8 minus p cubed is greater or equals to 0. Then from there, how do we continue? We take the 8 or we can take the p to the other side. So we can say minus p cubed greater or equals to minus 8. The sign changes when you divide by a negative number or when you multiply by a negative number. But when you transpose, the sign does not change. Don't make this mistake. Some people will do this here. We'll say, oh, let's transpose the 8 to the other side, then the inequality changes. That's highly incorrect. We do not even consider what you're doing. So make sure that you don't commit that mistake. So what you need to do is keep it like that. You just transposed. You didn't multiply or divide. So it's minus 8. Here's the story now. It changes. So when you divide by -1, divide by -1, the sign now will change when you divide or multiply. So this is p to the power cubed. Then it's 8 on that side. Then we're looking for the values of p. So here I can say third root p cubed, third root of 8. Or someone might say, since you have p cubed, it's equals to 8. Someone might say 1 over 3, 1 over 3. Then this 3 will cancel, then p, no, I'm putting in equals to there. It's a less than. It's a less than. So here it should be less than. Less than what? Less than 2. Also here, when you put this in your calculator, you should get p less or equals to 2. So this is how we determine the values of p for the root to be real. Let's look at question 2. Question 2 says the first four terms of a quadratic pattern are 11, 20, 33, 50. Then the list goes on. Then it says determine the general term of this pattern in the form of Tn is equals to an squared plus bn plus c. So from here, what you need to do is we are working with a quadratic pattern. So for a quadratic pattern, you must make sure that you find the first difference and the second difference, where the second difference the second differences are equal. So let's try to do that here. So we are going to say 11, then 20, then 33, then 50. Don't forget, this is a sequence. So now we are going to find the difference. So 20 minus 11. What is 20 minus 11? It's 9. Then 33 minus 20, it's what? It's 13. Then 50 minus 33, it should give you 17. This is the first difference. I'll just say DIFF for difference. Then now we are looking for the second difference. Let's take a look what will happen for the second difference. 13 minus 9 is 4. 17 minus 13 is what? 4. This is your what? Second DIFF for difference. So now what you should remember is when you're trying to find the general term, you must know that for the second difference, we have let me wait for it. We have 2a is equals to 4. After finding a, then 3a plus b is equals to 9. 4, then the last one it should take 11. So we can say a plus b plus c, it's equals to 11. Then when you solve for a, b, and c, you should use that. So I'm going to say 2a is equals to 4. Then a, when you divide by 2 on both sides, divide by 2, divide by 2. What do you get? A is equals to 2. Then the next thing is, let's find b. So we're going to say 3a plus b is equals to 9. Don't take 13. It will be highly incorrect. Don't take 13 and above. So you must take 9. So we'll say 3 times, what is a? It's 2 plus b is equals to 9. Then b is equals to 9 minus 6. Because, okay, let me not rush to get the answers. So we can say 3 times 2, it's 6, plus b is equals to 9. From there, you say b is equals to 9 minus 6. Then b is equals to what? 3. This is our second solution. Then to find the third one now, we said a plus b plus b plus c is equals to 11. What is our a? Our a is equals to 2. Our b is equals to 3. Then we're looking for c. So 2 plus 3 is 5 plus c equals to 11. Then how do we find c? You transpose the 5 to the other side. Then you say this is equals to 11 minus 5. Then c is equals to what? 6. Now with that knowledge, you can find the general term. Remember that the general term Tn is equals to an squared plus bn plus c. What is a? A is equals to 2, n squared plus, what is b? B is 3, so 3n plus, what is c? C is equals to 6. This is how then we determine the general term. Then how do we mark this one? We are going to mark the A, the B, the C, then the general term, then you get 4 marks. This is easy marks to get. So learn how to go about this one. Then let's look at 2.2. 2.2 now. Okay, let me also create a room for 2.2. So this is 2.2. So 2.2, they say prove that the sum of the first nth differences of this quadratic pattern can be given by Sn is equals to 2n squared plus 7n. So this is Sn. What is Sn? The sum of the nth term where we are adding. It has to do with series where you are like plus, 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 then there are terms there. But we are not much interested in that. So what we need to do is we must go back to our workings. So let me try to go back. So for our first difference, this is our first difference. And the question says what? prove that the sum of the first differences of this quadratic can be given by. So we take that pattern. We say 9, we say 13, then the last one that we got is 17. But this is a pattern, it grows. So we must prove Sn. So what is the standard form of Sn? Sn, it's equals to n all over 2, then 2a plus n minus 1 and d. This is the sum for an arithmetic. So why are we saying this? Why did we choose the arithmetic equation? Someone might ask. Because of, we can say this is arithmetic because of the difference there, it's equal. When I talk about the difference as something like d is equals to t2 minus t1, we are not dividing, we were subtracting. Thus, it's arithmetic. But if we were dividing, now it's geometric. So thus, here we are going to use the arithmetic. So we are going to say Sn is equals to let me create a room. We already have everything that we need. We just substitute. So this paper was very, very easy. So what's the difference here? It's 4. What's the difference here? It's 4. Remember that the difference, when you talk about arithmetic, this is D. What is this 9? 9 is what? It's A. So we have A, we have D. So we can find what Sn is. So I'm going to say n all over 2. Then in the place of A, we put 9 plus n minus 1. Then in the place of D, we put 4. So I'm going to say Sn is equals to n over 2. 2 times 9, it's 18 plus 4 times n. This is 4n minus 4 times minus 1, it's minus 4. Then this is equals to, we can still say n all over 2. 18 minus 4, 18 minus 4 is 14 plus 4. From there, when we say, okay, we can say n over 2 multiplied by 14 is the same as n over 2 multiplied by 14 plus n over 2 multiplied by 4 is the same as n over 2 multiplied by 4. So here I introduce the multiply. So we're going to say this is equals to, how many times does 2 goes into 14? 7 times. So this is 7n plus 2 divided by 4, it's equals to 2. This is 2n. But there's a mistake that I did here. Here it's supposed to be n because of this 4n here, and 4n there. Then when we say n times this n, it's equals to 2n squared. So this is the Sn that they are looking for. Let's look at the mark allocation for this one. The mark allocation for this one is correct substitution, then you simplifying it. Yeah, it's either here or they're going to give it there, but it's 2 marks at the end of the day. For question 3, they say a convergent geometric series is given by, then they say 5x plus 1 divided by 3 plus, then it continues like that. 3.1, it says calculate the values of x. So when they say a series is geometric and it's convergent, they mean that R should be between what? -1 and 1. But they didn't say prove that it's convergent. So we do not really need this, but for knowledge sake, you really need it. So if a series is not geometric, then this rule doesn't apply. But let me not go there. They didn't ask that. So they say calculate the values of x. So for geometric series, we must understand that r is equals to t2 divided by t1, which can also be equals to t3 divided by t2. Then the list goes on. Or I can say, let me leave it there. Let me not make it complex. So what you need to do is, okay, let's take the 5x plus 1 all over 3 plus 5x plus 1 squared divided by 9 plus x plus 1, then it grows by 3, then it's 27. So they say we must calculate the x value. Remember this condition here. So I can say r is equals to term number 2. This is t2. This is what? This is t1. So I can say term number 2, which is 5 times x plus 1 squared all over 9. This is term number 1. Then divided by term number 2, which is this one here that will come, which is 5x plus 1 all over 3. Please rewind if you did not hear what I'm trying to say here. So now we are looking for x, the values of x. So we are going to say r it's equals to what? R is equals to, I can remove this division line by saying 5x plus 1 squared all over 9 divided by 5x plus 1 divided by 3. From there, you should change this division. So we'll say this is 5x plus 1 squared all over 9 multiplied by, when you change that, the 3 goes up, then 5x plus 1 goes down. Then here we have, it's the same as having a situation where they say x squared divided by x. So this is the same as saying x times x all over x. 1x will be cancelled. So we are on that now. So when we say we have 1 there, we have 2. When you divide x plus 1 squared all over that x plus 1, it should give you 5x plus 1, and divide by 3 goes 1 times, 3 goes how many times into 9? 3 times. So this is over 3. But I have a 5 there, I have a 5 there, so they will cancel. I shouldn't write that 5 because it will be cancelled. So this is our r value. But guys, they say determine the values of x. So I think that theory I was talking about, it will help here, because this series is a convergent series. So for convergent series, we must remember that r is between -1 and 1. So I'm going to now substitute the r. So I'm going to say x plus 1 all over 3 less than greater than 1. So what are you going to do here? You are going to multiply throughout by 3, because 3 is the LCD. So we are going to say -1 times 3, x plus 1 all over 3 times 3 less 1 times 3. Then -1 times 3, it's -3, less than 3 divided by 3, this is x plus 1, less than 1 times 3, it's 3. Then when you transpose this plus 1, you must do it for both. So we're going to say -3 minus 1 less than, no, let me wipe off this, minus x minus 3 minus 1. So the minus I've put for both the sides. So we're going to say -3 minus 1, it's -4. Then minus what? I keep on adding that line, I don't know. Then 3 minus 1 adds 2. This is your solution. These are the values of x. So the values of x are between minus 4 and 2. That will make sure that this series will converge. So now let's look at the mark allocation for this one. So, but there's a catch here. Yeah, there's a catch. X shouldn't be -1. That's a catch. Why? Let's try to put -1 in our geometric series. So when you say 5 times x plus 1 on over 3 plus 5 times x plus 1 squared all over 9 plus 5 times x plus 1 to the power 3 all over 27. Let's put the -1 there. So when you say 5 times, I get it's -1 there. So we say -1 plus 1 all over 3 plus 5 times -1 plus 1 -1 plus 1 all over 27. This will give you 0. This will give you 0. This will give you 0. The answer will be 0. We don't have a pattern. That's why now you must make an exception that x shouldn't be -1. So you get a mark for realizing that. You get a mark for writing -4, x between -4 and 2. Then another mark that you get is when you put x plus 1 over 3 between -1 and 1, you get another mark. So far, this is 3 marks. So I hope, guys, you understood. If you did not, try to rewind maybe 3 times so that it makes sense. What is important here is understanding, not just solving. So try to understand. Let's move to 3.2. They say, okay, 3.2. They say if x, okay, x is equals to 1, calculate the sum to infinity. So guys, sum to infinity, again, remember that sum to infinity works for convergent geometric series. So as infinity, you must remember that it's a all over 1 minus r. So what are we going to do now? We are going to say, okay, if x is equals to 1, yeah, so what is our r again? Our r, previously we got that r is equals to x plus 1 over 3. Rewind if you did not understand. X plus 1 over 3. Then they say if x is equals to 1, then you can substitute it directly there. So you can say r is equals to 1 plus 1 over 3. Then r is equals to 2 all over 3. So we got our first r. Then you ask yourself, what is a? Go to the pattern again. Go to the pattern again. This is a. When you look at this geometric series, this is a. So a should be, why am I not seeing this? It's fine for now. So a should be 5x plus 1 all over 3. You again substitute x is equals to 1. So we're going to say 5 times 1 plus 1 all over 3. This is equals to 5 times 2 all over 3, which is 10 all over 3. This is your a. So then you can substitute that and say a is equals to 10 all over 3 in the place of a, divide by 1 minus, what is r? R we got 2 all over 3. In your calculators, put brackets so that it's not giving you the wrong answer. So as infinity, you should get 10 when you put this in the calculator. So then how do they mark this one? If you got the correct substitution here, from here to here, you wrote the correct substitution, you get 1. For that final answer, you get then 2. That's how we answer the question 3. Let's look at question 4.1. Okay, the statement there, it says 1 minus x, then the second term, x plus 2, the third term, 2x minus 5 are the first three terms of an arithmetic sequence. Determine the value of x. So when we have an arithmetic, you must know that the difference d is equals to t2 minus t1 equals to t3 minus t2. So here we have a pattern, like, not a pattern, but yeah, a sequence. Okay, sequence, it's fine. Sequence and a pattern is one thing. So 1 minus x, then x plus 2, then 2x minus 5. Then what is d? D is equals to t2 minus t1 is equals to t3 minus t2. So we know that this is t1, this is t2, this is t3. So let's minus accordingly, or let's substitute accordingly. So t2, it's x plus 2 brackets minus, what is t1? It's 1 minus x. This is equal to t3 then is 2x minus 5. No. It's minus x plus 2. From there, we are going to say x plus 2, then minus times this 1, it's minus 1. Negative times this minus x is positive x. This is equals to 2x minus 5. Then we take this minus to that x, it's minus x. Minus times this 2, it's what? Minus 2. From there, we add the like terms. So we're going to say x plus x is 2x. 2 minus 1, the answer is 1. This is equals to 2x minus x, it's x. Then minus 5 and minus 2. Please put this in your calculator. Many people are making mistakes here. So minus 5 minus 2 is minus 7. From there, you say 2x. You bring this x to this side. When you bring x to that side, what happens? It will be minus x. This is equals to minus 7. You take this one to this side, it becomes what? Minus 1. Then 2x minus x, it's x equals to minus 7 minus 1, it's not equals to 6. It's equal to minus 8. Please put this in your calculators. Stay safe always. So x is equals to minus 8. How do we then mark this part? So for the method, but we are not marking that now. For the method, we give you the mark. Then you simplifying this into that, we give you a mark. Then the final answer, you get 3 marks. Then let's move on to 4.2. So please, if you did not understand 4.1, please rewind. Let's move to 4.2. 4.2. 4.2, they say if the first 3 terms of this pattern are 9 minus 6 minus 21. Then they say calculate the numeric value of the sum of the first 110. So they're looking for S100. And for arithmetic, you must remember that Sn is equals to n all over 2a plus n minus 1. Then there's d there. Then this is equals to, where I see n, this is the same as, where I see n, I put 100 all over 2. 2 times, what is a? A is the first term, which is 9. This is a. So you say 9 plus, what is n again? It's 100 minus 1. Then what is d? We must look for d. Or let me see. Yeah, we must look for d. So we have 9 minus 16 minus 21. So d is the difference of minus 6 and 9. So minus 6 minus 9, it's minus 15. Minus 21 and minus 6. Okay, minus 21 minus minus 6, it's equals to minus 15 again. So it's minus 15. Okay, of that. So it's also minus 15. So D is what? Minus 15. So let me wind up where we're going to use that. Okay, let me restart. Then continuing, what are we going to do? We're going to say S100, the sum of 100 terms, it's equals to 100 all over 2, it's equals to 50. Then 2 times 9, it's 18 plus 100 minus 1, this is 99, open bracket minus 15. Then here you should just put this in your calculator. What do you get when you put this in your calculator? It's minus 73,350. Then how do we then mark this one? For substituting correctly, you get a 1. For the final one, you get another mark. So this is 2 marks. Let's look at 4.3. 4.3, it says, hence or otherwise, calculate m if the sigma m minus 1, then they give you from n is equals to 0, then it ends to m minus 1. Then Tn there, it's 24 minus 15, and it's equals to S100. We already found S100. Then plus 73,320. So what is important here? Let's say we have a sigma, n is equals to 0, then it ends at 8. Then I ask you a question that how many terms are in this sigma? So many would say 8, but the correct answer is 9, because to find the number of terms, must say the bottom number minus the top number minus the bottom number, which is 8 minus 0. Then always add a 1. Then what is this equals to? It's equals to 9. There are 9 terms. Let's do last example. Let's say we have a sigma n is equals to 2, then it's 8. So how many terms are there? So number of terms, it's equals to the top number minus the bottom number plus 1, which is 8 plus 2. No, not plus 2. 8 minus 2 plus 1. So 8 minus 2 is 6 plus 1 is equals to 7. There are 7 terms. So what am I trying to achieve here? So when you say 9, when you say there are 9 terms, when it starts from 0, we know that the last number it's at n is equals to 9. That's what I'm trying to achieve here. So let's try to answer this question without me going deep into this theory, but it's just a revision. Space, space, paste this again. So we are going to say what? The number of terms, n. You can say n is equals to what? 0. No, not 0. What is the top number? It's m minus 1 minus 0 plus 1. So this is equals to what? M minus 1 plus 1, which is equals to m. So it means n is equals to m. This is the first thing to take into consideration. So the last number of the series is m. So where I see n, I can put m. So very important. Rewind if you did not get this one. Then secondly, we must now take this and break it and expand it into series. So I will say sigma m minus 1, n is equals to 0, then 24 minus 15 n. This is equals to, you substitute this 0, you say 24 minus 15 times 0 plus 24 minus 15 times 1 plus 24 minus 15 times g. This then is equals to 24 minus 15 times 0 is 0. So this is 24 plus 24 minus 15. It should give you 9. Then here's the same as 24 minus 30, which is plus minus 6. So here we have the first three terms of this series. So we have A, which is 24. Now we are looking for D. For D, you take the difference. 9 minus 24, it's what? It's minus 15. Minus 6 minus 9, it should give you minus 15 again. So what does this tell you? It tells you that this is the second difference. Not the second difference, it's the difference. I mean, we are not talking about quadratic. We are not talking about quadratic, but we're talking about arithmetic series. So this is D. So we have A, we have D. So now we can solve this question. Let me try to copy this because it's very important. This is our reference to answer this. So I can say copy. Then let me try to paste it here. Using the information that we have, the first information is that n is equals to m. So you know that Sn is equals to n all over 2a plus n minus 1, then d. Then we know that this is equals to the sigma. In a way, this is m minus 1, n is equals to 0, then 24 minus 15n. So now we are trying to replace this and put this. So we are going to say n all over 2a plus n minus 1 d is equals to the S100 plus the 73,320. Then here we know that n, we said it's the same as m over 2. Then this is 2. What is a? We found a. A is 24. Remember, a is 24. So I'm going to say 24 plus, what is it? N, it's m minus 1. Then what is d? The difference, it's minus 15. It's minus 15. It's equals to, what is S100? We already found S100. It's negative 73,350 minus 73,350. From there, we say this is plus 73,320. From there, what is going to happen? Here we can just find a straight answer. When you take negative 73,350 plus 73,320, it should give you minus 30. Then let's work on the left side. So you're going to say m all over 2, 2 times 24 is 48, plus, let me start with the plus, it's fine. Plus, so I'm going to say minus 15 times m, it's minus 15 m, minus 15 times minus 1, it's plus 15. From there, so you'll say m all over 2, then 48. Then now you know there's a silent one there. 1 times minus 15, it's minus 15 m. 1 times this 15, it's plus 15. This is equals to negative 30. From there, you're going to say m all over 2, 48 plus 15. What does it give us? It gives us 5 plus 8, and then it's equals to 3163 minus 15 m. This is equals to minus 30. From there, I can just multiply both sides by 2, both sides by 2. So what do I get by doing that? This 2 and this 2 will cancel. Then I'm left with m 63 minus 15 m. It's equals to minus 60. From there, I distribute the m there. So what is going to happen? I'm going to get 63 m minus 15 m squared is equal to minus 60. Because of I'm getting minus 15 m squared, I can take it this side. So I can also take that one to that side so that I'm left with 0. 0 is equals to 15 m squared minus 63 m minus 60. We just found the 60 on the right hand side, so we cannot change it. So it's minus 60. Then from there, we use the quadratic formula. The quadratic formula says, now we are looking for m. Don't say x, say m, it's equal to minus b plus minus the square root of b squared minus 4ac divided by 2a. So what is a here? It's 15, c is minus 63. B, this is b, then c is minus 60. From there, you're going to say this is equals to minus. What is b? It's minus 63 plus minus the square root of minus 63 again, squared minus 4. What is a? It's 15. C, it's minus 60. This is divided by 2 times. What is a? A is 15. From there, we say it's equals to the first value that you get, it's 5. Or m is equals to minus 4 over 5. M is equals to this 5, or m is equals to this minus 4 over 5. Then how do we then mark this? For you to get minus 30, you get a mark. For you to write this part, let me see which part, this one, you get a mark. For you to find the standard form, let's go straight to the standard form, this one, you get a mark. Then for you to get this 5, you get a mark. But here, we cannot have m that is negative. So we must reject this statement. So for you to reject, you get this 1 mark here. You like, it goes with the mark. So if you didn't reject, so you're not getting that 1 mark. So here you must get 4 marks in total. Let's do question 5. So question 5, they say the graph of f of x is equals to 2 all over x plus p. Remember that let me remember that P is the movement in the horizontal. So the movement in the horizontal is what? It's P. So these points, which are X points, this is the movement of P. Then the movement of Q, it's what? It's the Y. This is the movement of Q. These are Y values. So when you think of P, think of X. And then here, P is close to X. Q is plus this whole equation. So it's something that you can remember. P, Y, then Q. P, it's X, then Q, it's movement in Y. So let's answer the question. They say write down the values of P and Q. So we have of f of x is equals to 2 all over x plus P plus Q. So let's draw a Cartesian plane. I wanna just illustrate something here. So let's say there's no Q, there was no P. The graph was just 2 over x. This graph would have been something like this. If there was no P and the Q. But now, when we say, let it move to this 3 here, it moves in the x direction. So this is minus 1, minus 2, then minus 3. So the graph will be shifted to that other side 3 units. So let's try to figure out the answer. So P is the movement in the x. So we know that it went 3 units to the left. It went 3 units to the left. So we can just say P is equals to 3. Then Q, the graph then went down how many units? Negative 1. So we will say negative 1. Let's discuss the P. If the P, the graph goes this side, then P, and this side is the negative side, P should be positive. But if the graph moves this side, and you know that this side is positive, then P should be what? Negative. Let's say it moved 3 units this side, it would have been negative 3. But now it moved to the left. So P is minus 3 instead. Then, okay, we found our answers. So how do we mark this one? P being 3 and Q being negative 1. Then you get your 2 marks. Then let's move on to 5.2. 5.2, they say the straight line of g of x is equals to negative x plus k is one of the axes of symmetry of the graph of f. So let me wipe off this so that I can also explain what they're talking about. So when they say the axis of symmetry of the graph of f, but the x here is negative, so the line should be passing something like this. So this is the straight line. The line is something like that. So this is not y. This is g of x. It's equals to negative x plus k. So we are looking for k. But this line touches those two asymptotes. What is that point of that asymptote? Let me wipe off this because it might confuse someone. Let me just say the point here is what? The x point is minus 3, the y point is minus 1. So we are going to use that to find g of x. We are going to say g of x is equals to negative x plus k. So in the place of y, we put minus 1. In the place of x, we put minus 3. But x was negative, so let's not forget the negative plus k. The negative 1 is equals to 3. Negative times negative is positive, and we say plus k. Then minus 1, we transpose the 3, then we get minus 3 is equals to k. Therefore, k is equals to minus 4 when you add minus 1 and minus 3. Therefore, you conclude, you say, not f, this is g of x is equals to what? Minus x minus 4. This is the final answer for 5.2. Then how do they mark this one now? The correct substitution and you getting k is equals to negative 4. This is now 2 marks. Then let's move to 5.3. If you did not hear me for 5.2, please try to rewind. It will make things easy. So 5.3. 5.3, they say if h of x is equals to h, now it's a new graph. It's equals to negative 2. Okay, let me write it down. H of x is equals to minus 2 g of x. So g of x, we got minus x minus 4. So without even reading the equation, I can just substitute minus x minus 4. I know that the new h of x now is equals to minus 2 times minus x, it's 2x, minus 2 times minus 4, it's plus 8. This is the new h of x. But what does the question say? It says determine the equation of the inverse of h. So we must determine the inverse of h. Remember that when we talk about the inverse now, we have to interchange the x and the y. So we are going to say the inverse. So for the inverse, now you know that, okay, we have h of x is equals to 2x plus 8. We are not going to use h of x. We must use y instead. So we're going to say y is equals to 2x plus 8. Then we must interchange. So I'll write interchange. This step you must interchange. So y become x and x becomes y. Then this is plus 8. From there now you solve for y. You say transpose this 8 to this side, it becomes x minus 8, it's equals to 2y. Then divide by 2 on both sides. Therefore, y is equals to what? X minus 8 all over 2. Then you can simplify further and say y is equals to x all over 2 minus 4. And this is the final answer. But we are not just talking about y, we are talking about h inverse of x. It's equals to x all over 2 minus 4. Then this is the final answer. Then how do we then mark all of this work? You getting h is equals to 2x plus 8, you get a mark. Then another thing is you interchanging this step, that's why I wrote interchange. This step you get marks for just interchanging. Then another mark goes to the h inverse. So this is 3. Then let's look at 5.4. 5.4 will lead us to draw now. So let's listen to the question. It says draw a neat sketch of the graph of h. Okay, h, we got what? We got 2x plus 8. We can say 2x plus 8. Then h inverse of x, we got x all over 2 minus 4. So now we must find where, okay, before I go there, let's finish the question on the same set of axes, right? Then clearly show all intercepts. That's important. We must show intercepts. With the axis point of intersection. That's number 2. Point of intersection. Then the third one, and the axis of symmetry. The axis of symmetry. So let's start with the intercepts now. So you can just say this is the h of x equals to 2x, man. It's 2x. Let me wipe off that. 2x plus 8. And that side we have h inverse of x is equals to x over 2 minus 4. Then let's look for the y-intercept. Y-intercept. For y-intercept, let x to be equals to 0. So I'm going to say y is equals to 2 times 0 plus 8. Y is equals to what? 8. Therefore, you write the coordinates. X is what? Is 0. Y is what? It's 8. So we have found the y-intercept. Now let's go to the x-intercept. For x-intercept, y must be 0. So we are going to say y is equals to, instead of rewriting that, in the place of y, put 0 is equals to 2x plus 8. Remember that we are using this. So we are going to transpose the 8 and say minus 8 is equals to 2x. Therefore, x is equals to minus 4 when you divide on both sides. Therefore, the coordinates are minus 4 is 2, 0. Then also this side. For y-intercept, x should be equals to 0. So you're going to say y is equals to 0 all over 2 minus 4. Therefore, y is equals to minus 4. Then what are the coordinates? 0 is to minus 4. Then let's look for the x-intercept. For x-intercept, y should be equals to 0. So you're going to say 0 is equals to x all over 2 minus 4. Then you take the 4 to the other side, it becomes 4 is equals to x all over 2. Then you multiply by 2 on both sides. So 2 times 4 is 8. This is equals to 2 cancels 2, then x is equals to 8. Therefore, you write the coordinates. 8 is to 0. Then now we have the intercept. Then let's find the point of intersection. We are on this point now. This one we are done intercept. Now we are looking for the point of intersection. At the point of intersection, intersection has to do with two lines that cross each other. So it's y and their y value and their x value, they are equal. So I'll just say intersection. For intersection, I can say y1 is equal to y2. So y is the first one. So I'm going to say 2x plus 8 is equals to y2. That's what? X over 2 minus 4. So now we're solving for x. We must take this minus 4 to the other side. We say 2x minus 4. Now it's plus 4 plus the 8. We leave the 8 there. It's equals to x all over 2. Then I get 2x plus 12 is equals to x all over 2. Then I'm looking for x. I should multiply by 2 on both sides. Multiply by 2. The 2 will cancel. Then we have x. Then we're going to say 2 times 2x is 4. x. 2 times 12, it's plus 24. Then I'm going to say 4x minus x is equals to the 24. You bring it to the other side. It gives you minus 24. Therefore, 3x is equals to minus 24. Then what will happen here? We're going to divide by 3, divide by 3. Therefore, x is equals to minus 8. Then I'm looking for the point of y now. So I'll use the first one. Y is equals to 2x plus 8. Let me confirm if it's 2x plus 8. Yes. Then we're going to say y is equals to 2 times minus 8 plus 8. Y is equals to 2 times 8, it's minus 16 plus 8. Then y is equals to 8. Therefore, the point of intersection is minus 8 is to minus 8. I made a mistake here. It should be minus 8. Put this in your calculator, you'll get minus 8. Be careful of that. So we have found the point of intersection. Then the last one now that we should get is the axis of symmetry. The axis of symmetry, it's easy to get it when now we have drawn the graphs. So let's just draw our graphs. So let's start with the intercepts. The intercepts, we have 1, we have 2, we have 3, we have 4. So for y values, 8 is the biggest. I can see that 8 is the biggest. And for x values, 8 is the biggest. So we are going to draw a straight line there and another straight line. So here you'll write 8. For the sake of time, I'll just write 8 there again. Then another thing is okay, the intercept, we have minus 4 and minus 4. So I have minus 4. Okay, minus 4 here and minus 4 there. For the sake of time, I'm trying to save time. So I don't want to write everything. After drawing, you should get this diagram. So this, remember that this is the point of intersection. Then this line, the broken line, y is equals to x. That's the line of symmetry because it passes through this 0 here. Then these are your intercepts. Very important. These are your intercepts. Then what am I missing? You labeling the graphs. This is H, then that is H inverse. So how do we then mark? If the shapes are correct, then we give you a mark. If the x and y intercept are correct, we give you the mark. Then if the intersection is correct, we give you a mark again. Then if the axis of symmetry passes through the point of axis, through the point of intersection, I mean, then we give you another mark for that. Then this is 4 marks. Let's do 6.1. So question 6 now says the graph of f of x is equals to ax squared. Then they say g of x is equals to b to the power of x. Remember that this is a parabola and this is what? It's an exponential graph. Why is it an exponential graph? Because the x there is an exponent. Then from there, they say as sketched on the same set of axes. Point A, we have point A. Okay, let me go to this side. So we have point A, which is this one, which the coordinates is -1 is to 2, and B are the points of intersection. This is where it intersects. Then the graph of f has the turning point. The graph of f has the turning point at the origin. So we know that the turning point 0 is to 0. The x coordinate and the y coordinates are 0. Then 6.1 now, they say calculate the value of a and b. So for the value of a, it comes from this parabola. Here is a. We just say f of x is equals to ax squared. But in the parabola here, I'm given point a. So I'm given point a, which is -1 is to 2. This is x and y. So in the place of x, I put -1. So I'm going to say, yeah, in the place of y and I put 2. So I'm going to say 2 is equals to a times, in the place of x is -1, then it's squared. Then you continue, you say 2 is equals to a times, when you take -1 squared, when you put it in brackets, it gives you 1. So this means that a, okay, let me write it clearly. It means a is equal to 2. This is what a is. Then let's try to find b. For b, now we use this one, the small letter b, not the big letter b. So this one is the biggest one. This is the big letter. So we're not trying to find that. We are trying to find this b. So we're going to say g of x is equals to b to the power of x. Then you ask yourself, what point can you is it touching that graph? It's still a. So we're going to use the point a where -1 is to 2. From there now, you know that x is y is 2. So we're going to substitute. In the place of y, you put 2 is equals to b to the power of what is x is -1. So this is the same as saying 2 is equals to, according to laws of exponents, what is this equals to? That is equals to 1 all over b. Then you multiply by b throughout, you multiply by b throughout. This b will cancel. Then this side you have 2b is equals to 1. Then you divide by 2, you divide by 2. Therefore, b is equals to 1 all over 2. Then how do we then mark this? The first thing is you getting a is equals to 2. The second thing is b is equals to 1 over 2. Then that's your 2 marks. Then let's go to the next one, which is 6.2. 6.2, it says the inverse of f is not a function. That's true. So let me draw this side. So let's say this is the function of f. Let me draw the exact function. So the inverse of f, it's something like this. This is the inverse of f. So it's not a function. When we draw the vertical line test, when I draw this line and it touches 2 points, immediately it touches 2 points, that's not a function. So for it to be a function, it has to touch only 1 point. So if I erase this part, so for it to be a function, it must have only 1 point. So here it has 1 point. So let me use different colors. So this part is the opposite of that part. So now this is a function because it touches only at 1 point. So the question here is, I just want to go straight to the question. So the question here says, the inverse of f is not a function. We just saw why it's not a function. They say write down at least one condition which can be used to restrict the domain of f such that the inverse will be a function. So remember the blue color here. So this function is the opposite of this one. So the first domain should be x greater or equals to 0 because I've chosen this part. So from here it's 0, going that side it's positive. That's why I said the first condition, let it be x greater or equals to 0. Then the second one now, for this to be a function, I have to take that second one. But if I take this second one now, I must make sure that the vertical test only touches 1 point. So what must I do to make sure that it touches 1 point? I must erase this part here. Erase this part. So it should be something like this. So this is also a function because it touches 1 time. So from here going that side, that's your second domain or the second condition. So you must say x less than equals to less than or equals to 0. That's your another condition. So, but how do we then answer this question? You must say x greater or equals to 0 or x less or equals to 0. This is how we should answer this question. Then how do we then mark this? So someone might choose this one and will give you a mark. Someone might choose this one and will give you a mark. If you wrote both, then it will be 1 mark. At the end of the day, this is 1 mark. So there are 2 ways to write it. The first one is this, the second one is that. But you must understand both the situation. They might ask you different question on this, so just know all the ways. Then let's go to 6.3. Let me change the color here. 6.3. So for 6.3 now, they say for which values of x where x as an element. Let me create a rule so that we can understand the diagram here. Let me try to wipe off everything. Yeah, that's fine. Where x as an element from negative infinity, there's a negative infinity here to what? To 0. So we are concerned about this section. We are concerned about this section. That section, we are not even considering that section because of this restriction here that we are given. Will make g of x less than f of x or equals to that. So let's check where g is small in terms of y. So this graph, remember that this graph is g, this graph is what? It's f. So where is f greater than g? So let's compare the two distance here. Which one is at the top? Which one is at the bottom? F is at the bottom. G is at F is at the top, then G is at the bottom. So this means that G is less than F, and that's what we are required. So from this point, going that side, it will remain like that. But from here, going downwards, let's check. Here we have F, here we have G. So F now it's small. Here, F it's smaller than G, and our condition says G must be greater. So this part also doesn't work. So the part that we should write at the end, that's this one. So we must say, maybe you say x from You can say x is an element from -1 to negative infinity. Mara, it's wrong to write this. Someone might write like this. This is highly wrong. So you must say x as an element. You start with the smallest one. It's minus infinity to what? To -1. This is how you should answer this question. Or someone might say x it's less or equals to -1. That is also correct. So how do we then mark this section? Critical point. For you to choose the correct critical point to give you a mark, for you to give the correct notation, we give you another mark. So this is 2. So this 2 we might give you here, or we might give you here. So it depends which method you use. Then let's go to the last question. But before I move to the last question, let me create a room for this. Take us 2 seconds to finish. So if you didn't understand the previous explanations, and just try to rewind and take your time. Like don't rush to understand, but to try to make sense in what is happening. Okay, let me not go talk much, but let me do that. So let's do 6.4. So for 6.4 now, they say if h of x is equals to g of x plus 3. I don't even care about what happens next, because I know that g of x is equals to what? It's equals to 1 all over 2 to the power of x, because our b value was 1 all over 2. So now I'm going to say h of x it's equals to. So in the place of x for g function, in the place of x, I put x plus 3. So I can say 1 all over 2. In the place of x now, I put x plus 3. That's the new function that we have of h of x. This then will give you a direction to where we are heading to. Then from there, they say write down the coordinates of A prime. A prime means this is a new graph, the point of a new graph. The new coordinates of A on the graph of H. So guys, we have this graph transforms from G to H. So we must do that. So what happened to the x-axis? So remember that on the x-axis, when you say x plus 3, it means the graph moved 3 units to the left. But if you say x minus 3, it means the graph moved 3 units to the right. So that is what is going to happen. So you know here that we have -1, then somewhere here we have -2, we have -3, then continuing, we have -4. So the graph will move 3 units to the left because it's plus here. So we're going to say 1, 2, 3. So it will be there at 4. All the points will be moved there. Even the B point will be moved 1, 2, 3. The B point will be somewhere here. So this is the B prime. This is the A prime. But for A prime, the 2 remained like that. So what are the coordinates of A prime? Let me fix this. So our new A, which is A prime, is then -4 is to 2. So now you can construct the graph like that. That's our new exponential graph. So what is the answer for 6.4? 6.4, the answer is a prime minus 4 is due 2. Then, now we are going to an important part of this topic. They say a double prime. Okay, let's see the mark allocation before I move on. The mark allocation on this one is just 1 mark. For you to get negative 4 is to 2. That's 1 mark. Then let's move to 6 point. Okay, this is 6.4.2. 6.4.2, they say the new coordinates of A on the graph of H inverse, the inverse of H. So the inverse of H, let's draw a rough sketch. So if we have a graph like this, how do we then find the inverse? So the inverse, you know that it has the line of symmetry like that. So the new graph now, instead of it going through the y, it goes through the x. So like it's the opposite. But let me check something here. Yeah, something like this, the new graph. So the advice I would say, if for a prime you have minus 4 is to 2, then for it to reflect through the y is equals to minus x, now it will change to a double prime 2 is to minus 4. This is the answer. I don't want to go deep into the explanation of this because of time, but I think I'll make a separate video that explains why they change. So how do we mark this one? We get 2 marks for writing that. So this is your 2 marks. Thank you very much for watching this video. Make sure that you like, you subscribe, you share.